Okay, so good afternoon. Welcome to my electrical circuit analysis oral exam. My name is Sebastian Planas. And to start with the first question, so it was the case of resistance that was an LED, and we had to search for certain values. In this case, the protection resistor R1. So they gave us the conditions for the RED, for the red LED, which is in the middle of the range in voltage of 1.8 volts to 2.4 volts. We needed the middle of the range, which is 2.1 volts for this exercise. As well, we had the nominal current of 20 milliamps, which is 0.02 amps. In this case, we used the properties of the voltage in series, which is total voltage equals many voltages divided. In this case, we had the total voltage of 8.7 from the battery source, and we equal that to the voltage in R1 plus the voltage in the LED. And we had that the voltage in R1 is equal to 6.6 volts. As well, I used the properties in series for the current. In this case is IR1 equals IL1, which equals 0.02, which is the nominal current. All the current in series is the same. So the current in IR1 is equals 0.02 R1 due to Ohm's law. We substitute and we have 330 ohms. As well, for the protection resistor, we only have 220 ohms, 100 ohm resistor. Is it possible to build a circuit? Well, the truth is that it's not, because the way that we can obtain the more resistance is by connecting it in series, which we obtain 320 ohms, but 320 ohms is 10 ohms too short. As well, we can see that I made the comparison with the parallel circuit, and it's way less. So the answer is no. With the given information, we had the case of a defibrillator. So what electrical variables must be considered to guarantee the maximum energy of delivery in a modern defibrillator? So when talking about energy, we talk about power. And this power is measured in watts, which is joules over seconds, and we have joules on seconds. So the way to consider to guarantee the maximum energy, we use the formula power equals voltage multiplied by the current. And with this multiplication, we know that the electrical variables are current and voltage. As well, to guarantee that a modern defibrillator charges in 10 seconds at most, we have to consider some things. We have to consider the left part of the circuit that I drew here, which is when the capacitor is connected to the voltage source. So in this case, we need to upgrade the voltage source, so we have more volts flowing towards the capacitor, and we need to lower the resistance. This is going to increment the current, and this is going to result in more charge in less time. So how can you obtain the maximum current that is delivered to the heart during a heart rate activation? Using a defibrillator of any kind. So in this case, we use the formula of current in case when the capacitor is getting discharged, right? So in order to maximize the current, we need to make a smaller the exponents in the Euler. So how can we do this? Well, first of all, we can upgrade the resistance, and this is going to make this number smaller, and is going to increment the current. We can upgrade the voltage, that is going to increment the current as well. And the most effective one, we can upgrade the capacitance, because when we upgrade the capacitance, that exponent becomes smaller, and the proportion of the voltage between the resistance, which is the current that is actually flowing, is more than if we just upgrade the resistance or upgrade the voltage. As well, we using the information to determine the power. Well, we had the seconds, and we had the joules in the minimum energy in the range, which is 150 joules. We know that the formula for watts is joules over second. So the power in the modern defibrillator would be of 7,500 watts, 7,500, which is depicted here. So next, finally, based on my answer in the previous question, I have to mention of these two factors that can prevent the heart from receiving enough current for the reactivation of the heart rate, right? So the problem is not enough currents. So we didn't have enough voltage. We know that power depends on voltage as well, which is actually the energy that it's flowing. And as well in Ohm's law, we know that the current equals voltage between the resistance. So the bigger the voltage, the more current we're going to have, as well as in the, well, here's the charge. So we didn't have enough capacitance, which would be actually same, a very similar process as the voltage, because in the capacitor is where we store most of the energy that is going to flow towards the heart. So we wouldn't have enough capacitance or not enough voltage, we're not going to have enough current. So yeah, that was my exam. Thank you for being patient, and that's that. Thank you.